Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are looking at a P1 paper. The paper revolves around two topics, that is trigonometry and binomial expansion. Let's look at question number 1. It says in the binomial expansion of this bracket raised to power of 5, the first three terms are such and such. Find the remaining three terms of the expansion. Now you can write out the first term, that is 5c0. 2x raised to power of 5 and negative 1 over 2x raised to power of 0. So now from this one you can judge that the terms were expanded in the usual manner, and that is the first term. So 5c0 will give me the first term, 5c1 will give me the second term, 5c2 will give me the third term. So therefore for the fourth term I am writing 5c3 and then 5c4 and then 5c5. And then you just write it out just the normal way. That is 5c3, b raised to power of 3, a raised to power of 5 minus 3. The pattern continues. Take care of the positive negative sign. There is a negative, negative, negative over here. Negative raised to an odd power remains as negative. Negative raised to an even power becomes positive. Use a calculator, use the NCR function, simplify. These are the first three terms, actually the last three terms of this expansion. Because the power is 5, the first, second, third, fourth, fifth, sixth. So that is the total, all the terms that is possible. Now over here you have to make a wise decision. Hence find the coefficient of x in the expansion of this. So we have a simple bracket, that means a bracket with a power of 1 in which no binomial expansion is needed. And this is from part 1. Now you have to decide for yourself. There is a constant 1 over here that should multiply with the x term from this bracket. That will give me overall x. And this x square from here can multiply with this 5 over x. And are there any other terms? No. There is x cubed, there is x5, all these things, but there are no relevant terms over here. Let's say if something was given from the first bracket as 5x cubed and let's say 5x square, that is already there. And if it was 5x4 and if I would multiply it with x5, so that will give me 1 over x, but no more x. So you just pick the relevant terms out of it. And it so happens that after that multiplication, this 1 multiplying with the x term and this x square multiplying with this x square term, so like this and like this, and you get an overall 0. In other words, there is no term in x in the overall expansion. That is what it means. Question number 2. It says show that tan theta over 1 plus cos theta, tan theta over 1 minus cos theta is 2 over sin theta cos theta. The very first thing that I did was to take tangent theta common and then write tangent as sine over cos. That's the first thing. The next thing is this is 1 plus cos theta. This is 1 minus cos theta. And then you take LCM. So 1 minus cos theta goes over here. 1 plus cos theta goes over here. In the denominator, they both multiply like this. So that is a squared minus b squared. And we know that sine squared plus cos squared equals to 1. Therefore, 1 minus cos squared is actually sine squared. So that is how this thing is changed. And then you do the simplification and then you get this answer. So that was pretty obvious, nothing special. Hence solve this equation. Now this equation that is right over here, the left hand side of this equation, isn't this the same thing as this thing over here? That is what you have proven. So therefore 2 over sine theta cos theta is replaced, and this is equal to 6 and over tan theta, 6 over tan theta. And then you cross multiply, and before that you write tangent as sine over cos. Since tan is in the denominator, so 1 over tan becomes cos over sine, that is cos over sine. So let me also highlight this thing. So therefore tangent 1 over tan becomes cos over sine. And then you cross multiply, and the most important instruction, which I hope everyone remembered because it was emphasized many times in class. Don't cancel whenever there is a possibility of taking common. So whenever there is a possibility of taking common, always take common. So you take common and then it will also give you the solution. So now sine theta is 0, cos s plus minus 1 over root 3. Sine theta equals to 0. You can draw a small sketch. So let me draw a small sketch over here, just a basic one. And we know that there would be how many cycles? There would be one cycle in 360. So let me just draw it like this. That's like this and like this. But it so happens that all the values are out of the range. It's between 0 and 180. So 0 is there, 180 is there, 360 is there, out of range, out of range. Therefore, there are no solutions out of this. But you have to show the working. Keep that in mind. And then it says cosine theta is plus minus 1 over root 3, all 4 quadrants officially, but because of the limited range, only first and second quadrant are now applicable. Basic angle is this thing. Work in at least 4 SF. My bad. In at least 2 decimal places. Because the very, very final answer is 1 decimal place, because we are talking about angle in degrees. So do not mix up, as I was about to mix up, between significant figures and decimal places for degrees. It's about 1 decimal place. For everything else, including angle in radians, that is work in 4 SF, at least final answer 3 SF. First quadrant theta is alpha, second quadrant 180 minus alpha. Final answer is done. Question number 3. It is given that A is 2 sine plus cos. Sine theta is written as S, cos theta is written as C. B is 2 cos minus sine. Theta lies between 0 and 360. There are 2 parts. Show that A square plus B square is constant for all values of theta. Sometimes they can say it's independent of theta. It means the same thing. What I do is that A is 2s plus C. I square it, A plus B whole square. You are studying binomials, so you should be very well aware that you will be ending up with 3 terms because the power is 2. That's A square plus 2AB plus B square. Similarly, B is 2C minus S. B square is 2C minus S whole square. That is A square minus 2AB plus B square. Now they are adding it up. So add it up. So these two, actually 4S square plus S square will add up. C square plus 4C square will add up. 4SC minus 4SC will cancel out. 5S square plus 5C square, 5 common. S square plus C square is 1. We end up with a constant. Given that 2A is equals to 3B, show that tan theta is 4 over 7. 2 times A, so this is A over here, that is 2A is equals to 3B. Simplify. So we get 4S, 2C, 6C, 3S, transfer all the S on one side, transfer all the C on one side. S over C, there is nothing in common, therefore we divide and we create tangent. So S over C, that gives you tangent. S over C is tangent. So tangent equals to 4 over 7. Back to the basics, the 4-step solution, that is first and third quadrant. Theta lies between 0 and 360 degrees. Basic angle is this much, at least 2 decimal places, 3 decimal places also good. First quadrant as it is, third quadrant 180 plus the basic angle. Final answer, since it's degrees, therefore the final answer is given to 1 decimal place. Unless otherwise stated. If they state give the answer in integer, we have to follow that particular instruction. Binomial, once again, expand the following in ascending powers of x up to and including the term in x square. 1 plus 2x raised to power of 5, 5c0, 2x power 0, 5c1, and then 5c2. Simplify, you get these 3 terms. So let me highlight it. These are the first 3 terms that you're getting. 1 minus ax raised to power of 6. Apply the same process and then you are getting this. Since there is a negative sign in the middle, sign alternates. Since there is a positive sign in the middle, all the terms are positive. Now it says in the expansion of 1 plus 2x raised to power of 5. That is the first bracket. So the first bracket is 1 plus 2x raised to power of 5. Second bracket is 1 minus ax raised to power of 6. The overall coefficient of x square is negative 5. Find the possible values of a. So now I'm interested in only the coefficient of x square. So I'm focusing on coefficient of x square. Now how do we get the coefficient of x square? What we will do is that we will take the constant from here and we will multiply it with the coefficient of x square. we will take the coefficient of x square from here, we will multiply it with the constant. So 40 into 1, that is the first thing, that is 15a square into 1, that is the second thing. The third one, the x will multiply with the x, so 10 into negative 6a. Just play around with the coefficients. And this equals to overall coefficient, that is negative 5. The rest is just history, that is middle term factorization. Simplify, a comes out to be 1 and 3. Always double check, find the possible values. Yes, both are the answers. So a is positive 1, a is positive 3, both are the answers. So it's a pretty easy paper, nothing special, except for one or two parts over here. Given that theta is an obtuse angle, theta lies between 90 and 180. Quadrant 2, only sign is positive. Now I prefer to do this by drawing triangles. I call it the conceptual questions. Sine theta is k. K can be written as k over 1. So this is the opposite, this is the hypotenuse, and this comes out from Pythagoras theorem. Pythagoras saves the day. Cos is what? Cos is adjacent over hypotenuse. Adjacent over hypotenuse, but since it's in the second quadrant, therefore we give it a negative sign. Similarly, what is tangent? Tangent is opposite over adjacent. Opposite over adjacent, again second quadrant, tangent is negative. That is what you have to do, nothing special. Now it says sine of pi, theta plus pi. Now pi is 180 degrees. Now currently the quadrant was between 90 and 180. Okay, so the quadrant was initially between 90 and 180. When I add 180, what happens? 90 plus 180 is 270. 180 plus 180 is 360. Now where is it lying? It's lying in the fourth quadrant. The first quadrant 0 to 90. 90 to 180, 180 to 270, 270 to 360. In the fourth quadrant, sine will have the same, the theta will have the same basic angle, but sine will be negative. That's one way of doing it. Another way I've shown over here, that is by diagram. This is theta, theta is obtuse. When I add 180 degrees, this basic angle over here, this basic angle, this one over here, no, blue color is already used. This basic angle over here is the same thing as this basic angle. Therefore, if sine theta was k in the second quadrant, now sine theta will be negative k in the fourth quadrant. Basic angle is the same. Since the quadrant changes, the value of sine changes. Okay, now coming back to this. Another question of a similar type. It says given that x is sine inverse of 2/5. What does it mean? It means sine of x is 2/5. Again a triangle, this is 2, this is 5, Pythagoras root 21. They're interested in cos square x. Cos x is written as this, cos square x 21 over 25. They did not have to mention the quadrant. Why? Because anyway we are squaring it. If it's positive, it will remain positive. If it's negative, it will become positive. Tangent is 2 over root 21 square, that is 4 over 21. I have done this thing alternatively also, according to the identity. Sin x is 2/5, sin square x is 4/5, cos square x is 1 minus sin square, 1 minus 4 over 25. My bad, after squaring it's 4 over 25. That is 21 over 25, and also double check. That's 25, that's 21, all got. Tan square, sin square over cos square, that is sin square, that is cos square, 4 over 21 remains. Now the last question, the most interesting one. Sketch the following trig graphs. Y is equals to 2 minus 3 cos theta. Theta lies between 0 and 2 pi. The coefficient of theta is 1. One cycle in 2 pi, we are given 2 pi. Now over here, first of all, in this deep blue color, I have drawn negative 3 cos theta. This is one cycle. Black marker. Over here, let me label this thing as 2 pi. And this is 0. Maximum is now 3. Minimum is negative 3, but it's flipped upside down. Basically, cosine is like this. Okay, so now it has been flipped. So I have drawn negative 3 cos theta. Now the negative value will give me the maximum. That will come out to be 5. And negative 3 plus 2 is negative 1. So now let's draw it very realistically, but what I need to do first is this thing. I need to shift this whole grid down because I need more space. Okay, and also let me erase this thing, and over here let me add this thing. Okay, so now I have the liberty of moving this thing up comfortably. I think that is good enough. And now I already have the pieces. So now let me first label this is 3. So approximately this is 1, this is 2, this is 3, this is -1, this is -2, this is -3. Now the pieces I've already kept it over here. Let me take this, and from -3 it will move up by 2 units like this. Let me take this thing up, it will join forces with this. Let me take this, it will go like this. And that is how this beautiful graph is drawn, done and dusted. So now the maximum value is 5. So this is like 4 and this is like 5. And the minimum value is -1. So you can also see it from the graph. The next one, 2 sine 2 theta plus 3 over 2. 2 sine 2 theta. Now first of all write the standard, which is 2 cycles in 360 degrees. But in 3 pi by 2 you will have 3 over 2 cycle. So just play around with this. 2 pi, 2 cycles. 1 pi, 1 cycle. 1.5 pi, 1.5 cycle. Maximum, in place of this right one, that would be 3.5. Minimum, that would be 0.5. Now what I have drawn is that first of all I have drawn till 3 over 2 pi. This is pi. This is pi by 2. And I need to shift it up by 1.5. So when I shift it up by 1.5, this is like 1.5 over here. And this 2 plus 1.5 is 3.5 over here. This is -2 and this is -0.5. That is positive. -2 plus this thing, this is -0.5. So let me write this negative over here. That is -0.5. Okay. So again the pieces are ready for us. Take this, add it up like this. Take this, join forces with this. Take this, join forces with this. Now it's kind of tricky. You have to get very close to it. Okay, all good and all done. So that is how this graph is done. Y is 2 sine theta plus 3 over 2. That's the final one. 2 tan theta minus 1, 0 till 180. 2 cycles in 360. In 180, 1 cycle. And the red one is 2 tan theta. If you want to, you can label a point. Not necessary, but you can. 45 degrees. This value is 1, but because of the 2, this is 1 into 2, which is 2. And then between 90 and this thing 180, there is 135. Touch the line, go left, that is -2. So this is 2, this is 1, this is -2, this is -1, this is 3, something like this. Now we are shifting it 1 unit down. It's not 1 unit up, it's 1 unit down. So let me grab this. Something like this. Let me grab this. And this is like this. So green one is 1 unit down. Okay. So that is the final graph. And I think that's all about it in this particular paper. So stay tuned for more content on mathematics with Shahab Yaqub.